Hi everyone, this is Saiteja from CSC AML section B. Today my topic is about a digital signal processor with IEEE floating point of arithmetic. Let's get into our topic. A small introduction. A digital signal processor called as DSP is a specialized microprocessor chip with its architecture optimized for the operational needs of digital signal processors are fabricated on MOS integrated circuit chips. They are widely used in audio signal processing, telecommunications, digital image processing, radar, sonar, and speech recognition systems, and in common consumer electronic devices such as mobile phones, disk drives, and high definition televisions, HD TV called as. These are the some examples. We can use these integrated circuit chips called as. This is the process called as the microprocessor chip. It is specifies specialized in the digital signal processor. Let's get into some more about the topic. Floating point applications. Programmers code most the about this DSP algorithm development in the high level language using floating point arithmetic because it's a large dynamic range. Often they convert the final implementation to assemble language using fixed point arithmetical. Historically, assembly language has provided the fastest speed while fixing point of arithmetic has provided the low cost. However, this conversion process is the time consuming, error prone, and difficult to test. Another approach of a software floating point is arithmetic implemented on the excited fixed point processors. Does provide an alternative. But the speed requirements of real time, these application usually limit the value of this approach. Thus, a full hardware implementation of the floating point arithmetic makes sense. Is about the digital signal process algorithm developing in a high level language using these floating point applications. Floating point features, we can see some of the features about the floating point features. Fixed point of signal process chips. Small is the fixed point of the digital signal process chips offered a cost effective solution by combining a hardware multiplier memory and IO peripherals with an instruction set that improves digital signal process called as this benchmark. Over the past 5 years, the signal chip solutions has included applications in communications and also computer and control equipments, radar, sonar, medical implementation, digital audio, automotive electronics. With the help of signal chips, we can morely included in the communication. Communication also we can use mobile phones. Mobile phones we can use these chips like audio transferring in not only audio. They have some other chips which will transfer our data and also conversation in the video call. Some of the such that and also we can see in computer and control equipment. In computer also nowadays we are using these chips. In previous days there is no such facilities using these chips. This now we are using these chips, we can see lot of changes and we can see the HD clarity of videos and also the audio clip of the videos. It will be very clear using these chips. So it will give the good solution as we compared from the past few generations back. We can see some medical instruments, and we can see nowadays we can see in hospital also we can see a lot of changes causing with the help of these signal chips. We can see some of the X-rays, not only X-rays, we can see the scanners and also some of the laser therapies. We can see they are using these signal chips to identify. And also previously noticed that in our heart, for some of them, uh, they are establishing the surgically a heart name as artificial heart. In that also, they are using these chips. With this chip, they will control the heart, how the functioning the heart, and what are the requirements, how to process in a good healthy way. They are using these chips, and also in the digital audio and also automotive electronics also. Standard achieves increased performance over other floating point formats. The standard guarantees errors bounds for floating point operations such as add, subtraction, compare, multiply, divide, square root conversion to and for decimal strings. With the help of the floating point formats, not only the chips, and we can also do some of the operations like addition, subtraction, comparing, and also not only these, we can see conversions to from decimal strings. Also, we can use these floating point operations. Floating point architecture. The chip contains a highly parallel CPU, DMA, RAM, ROM, two memory expansion ports, and a debugging port, all connected by parallel 32-bit buses. The CPU consists of three units: data, dual address generation, program control. The the floating point architecture is contain. It will build the chip contains a highly parallel CPU or DMA, RAM, ROM, these and also two memory expansion ports and a debugging port, all connected by parallel in a 32-bit buses. The buses is nothing but they which transfer the data from it will transfer the data from one phase to another phase. And the CPU consists of three units. One is data, and the another one is dual address generation, and the another one is program control. In the data, we can transfer the data and can store the any information. And this dual address generation, which means it will generate the address of the it will generate dual address of the particular stored data, and also the program control. It will control the program in the in the buses. It will help in the transferring data in a processing way. Each unit has a set of local registers and several concurrent execution units. All operations of the execution units are registered oriented rather than memory oriented. These are all are registerly oriented rather than memory oriented. Operands are read from the internal registers, modified by an execution unit, and stored in registers within the same unit. Each register file is multi-ported so that data transfers over the buses in parallel way. To transfer the data in a parallel way, the register file is multi-ported so that the data will be transferred in a parallel way. Executes unit operation. The architecture provides enough execution units to execute most instructions in a single instruction cycle. We can see the diagram how this process is occurring. It is a 32-bit bus. We can see the program control unit and also dual address generation. These are the directions of the buses to transferring the information. Here is a external address switch, and we have two ports, port A and port B. In the port A, we can say addresses, control, arbitration, and data. In the address, we can see the external address switch. In the control, called as a bus control, and the other one is external data switch. It will switch the data. Okay. In the port B, you can see address external address switch as a 32-bit. And the other one is a control bus, which controls an abbreviation, and the external data switch. These are the this is a processing, how the processing occur in the CPU are called as known as the programming control unit. It is a 32-bit bus. We can observe through this diagram. Programming modeling, a set of registers on which the instruction set operates completely represents the program view of the 32-bit CPU. Execution units modify the contents of these registers while load and store operations move data between registers and memory. Floating point or integer registers. We can see the how the integer registers on the floating point. So we can observe the variations from high level, middle, and low. How it was going on through the small diagram. Data unit implementation. The implements IEEE is single precision and single extension precision. A floating point architecture in a single cycle hardware SEP offers more precision and dynamic range than the SP for the same speed, thereby improving accuracy in intermediate calculations and vector operations. Math library functions such as transigentals, trigonometric arguments, reduction, and power functions are more efficient with single extended precision arithmetic. Data ALU block diagram. Here is a small diagram about the arithmetic logical unit of data. You can observe this diagram on the screen. We can see in the bottom. We can observe the IEEE floating point multiply unit. It will observe the inputs and it will give the outputs in the specific function unit. Through this, we can see the 96-bit data register file. Through that, it will format the convert, and it will take the outputs and give the inputs to the floating point, and it will perform the operations such as addition or subtract unit. We can see through the block diagram. Memory organization in 96002 as a dual Harvard architecture with two logical data memory space such as X and Y, and a logical program memory space of A9002 instruction requires up to three memory access, one to each memory space, each instruction cycle. In addition, a DMA transfer requires up to two memory accesses to the same or different memory spaces. Each instruction cycle, assuming zero wait states, a memory access is one instruction cycle alone. Thus, keeping the CPU and the bus helps accomplish five memory access each instruction cycle. Dual channel DMA controller. The controller provides two independent DMA channels that operates in parallel with the CPU. Generic memory to memory DMA transfers one word per instruction cycle up to 54 bytes per second. Since all 9600 peripherals are memory mapped, generic peripherals to memory, memory memory to peripheral, and the peripheral to peripheral DMA transfers are supported. Users can program each channel for a singular continued DMA transfer. The transfer rate can be throttled or controlled based on the internal or external handshaking flags. The DMA controller provides a distinct timing for maximum throughput on internal to internal or internal to external or external to internal and also external to external DMA transfers. These channel DMA controller memory expansion ports. The memory has dual buses. two independent but functionally identical expansion ports called port A and port B. As shown in the before figure, each port has its own address, data control, and uh, arbitration buses that multiplex the internal address and data buses of chip as required. Users can program the configuration of each port via the bus controllers. Full 32-bit addressing provides for large online database in graphics and image processing applications. Advanced buses such as Apple's macOS 11 Nubus also required a full 32-bit address bus to access other card slots using geographic addressing. On-chip circuit emulation, a dedicated serial port with on-chip circuit emulation that we named once, and debugging logical provides for software debugging and production diagnostics. This debugging capability accesses all internal and external chip resources in single or multiple process systems. The last five executed instructions remain in a history buffer for debugging through fast interrupts. Once eliminates emulation cables that cannot meet high speed requirements and provides field diagnosis and repair. Thank you all.